Hello, student. Okay, today our lesson is live. So I will continue the lesson for the past lesson. That's the resultant force. So hopefully, today attendant you need to key in the Google Classroom. There's a Google form. So got two questions only about the resultant force. So hopefully you can answer it. Then you get hundreds marks. Okay, today I will share my screen. Again, same like the notes I shared to you. So I go to show my screen first. Okay, so can listen or not? Can anybody just type in the chat room? Okay, I saw there's Iru. Iru, can you listen me? Okay, Lynette is here. Okay, hi, Yanru. Okay, can. So I can start my lesson. Okay, today my lesson, there's a lesson 1.1, same like what you learned that day. That day because I forgot for the record. So today I do inside the YouTube. So this one that means you can recall back. Okay, resultant force 1.1. Okay, let's see this one. This one already inside your notes. Okay, there's a talking about the two participants. They are competing for the tug and war, the competition. Okay, now you see the participant A. Okay, the participant A, they will pull. Okay, and the B also exert the forces. Then they create two forces. So this one forces, we call it as a pulling force. FA and also the FB. Okay, now you can see the FA and FB actually there's a both moving in opposite direction. So from here you find it, what determines whether the yellow crop, I mean the center one, to the rope is at the rest, move to the left and also the right. So we need to find out, okay, this one, the center, the crop, is it go to left or go to right? So if you go to left, means we find it the force exerted by the participant A is more than the B. Okay, if opposite, that means participant B will more effort lah. So we're going to see the diagram. Okay, so from here, just now just introduction. Okay, now we need to go through to the zero resultant force. Okay, zero resultant force, you need to remember the two words. Okay, first is the same magnitude. Okay, magnitude means value. Both sides the magnitude is the same. So you see the diagram, this is left 5 Newton, another one right also 5 Newton. Okay, then another word should be opposite direction. Okay, when they just put opposite direction mean you are balanced already now. So we can say the object now is stationary, or you can say the object is removed at the remain at the rest. Okay, so I can say this one resultant force, actually there's a zero after I minus lah, because normally we take 5 Newton, right hand side is a positive, then the left hand side should be the negative. So after that, plus and minus, they become zero. Okay, then we're going to show the next one. Okay, this one is an example for the diagram for the tug and wall. Okay, so you find it both sides also produce the same of the forces. Okay, so this one is a situation for zero resultant force. The object is now the situation is stationary. So when I draw the situation also like that, you must write FA equal FB. Then you draw the arrow must be the equal. Okay, now the second situation is left resultant force. Okay, that means left hand side they produce the force should be higher. Okay, you can see the diagram. Now we take the left hand side should be positive. Normally we ignore the negative because you don't want to explain. Okay, so from here we just take the left hand side should be 100. Okay, then after that the right hand side should be 40 Newton. So we take 100 minus 40 Newton. So the left one should be 60 Newton. 60 Newton go where? Must go to the left. So we call it as a left resultant force. Okay, from here we got two forces, different magnitude. Just now it's the same magnitude, now it's different magnitude. So object will move where? They must go to the larger force direction. Okay, just like this one diagram again. Okay, now 400 Newton apply to the left. Okay, another side should be 300. So that means finally they will go to the left hand side. Okay, so from here we're going to see the following. Okay, the situation now you call it unbalanced force. You also can call it that got resultant force. Go to where? Go to the left hand side. So when you write the equation, now the FA is more than the FB. So when we draw the arrow FA is longer than the FB, then we understood resultant force is left. Okay, this one is the opposite again. There's a right resultant force, means the right hand side, the force finally should be the higher. So you see the diagram, this one is a 5 Newton, this one is a 3 Newton. So after I minus, sure I left 2 Newton, go where? Go to the right hand side. Okay, so from here, this one also same the situation. Right hand side, they are using 500 Newton to put it. Another side, 450. So finally, you still left of 50 Newton. Go to the right hand side. So we call it this one is a right resultant force. Then we also can call it as an unbalanced force. If the question asks what is the resultant force final, so your answer should be 50 Newton go to right. Okay, you must mention the direction where the force to go. Okay, so this one is a diagram. Now you need to draw the FB should be longer and also the FB is more than the FA. Resultant force is right hand side. Okay, so from here we need to go through so many resultant force just now. We got stationary, we got left, we got right. So we need to find out what's the definition for resultant force. Okay, resultant force mean there's a single force. That means there's just one force only. Then that represent the vector sum of two. Actually, there's a calculation from the two or three because a single force after you minus, after you plus, then we get that one we call it resultant force. Okay, I no need to save already. I already is upload in the YouTube. So that means when you later you go my channel, that means you can see it. Okay, thank you. Okay, so from here the resultant force is a single force. There's a sum of the two, or you say more lah, three or five. You plus together, finally you left one only, is it? So that one we call it as a resultant force. Okay, so from here, first citation for resultant force, the force acting in same direction. I think the student is no problem for this question because the direction should be the same. So we just plus together. Okay, so from here, 5 and 3. So this one, same direction. So we just plus. Okay, if I just answer this one is a 5 Newton, is it correct or not? Okay, anybody can answer me? Okay, you just type inside the chat room. I can see your answer. Okay, you just type what's the answer for this question? Okay, 5 and 3, direction should be the same. Okay, wait the student give me the answer. Okay, I think the student 5 science 2, there's no problem already. You just type in the chat room. I want to find out is it you still understand this topic or not? Okay, 8 Newton, Jessica Ho. Okay, if you answer just 8 Newton, you just get half marks only. Okay, why I say you get a half mark? Because there's not full answer. Okay, Calvin also same. You just get half mark. Okay, so zero. Okay, so I want the correct answer is this one from the Euro Shaw. Okay, they give me the answer is 8 Newton. Okay, 8 Newton. After that, they got show the direction to right. Okay, to right. Okay, resultant force is a vector quantities. You need to find out final answer where the force to go. So the final answer you need to show there's a 800 to sorry, it's a 8 Newton to right hand side. Okay, so this one is a correct answer. More detail a little bit, Jessica. Okay, then we go to the next one. Okay, the next one is a citation 2. Okay, now the citation is the force acting in opposite direction. So I show you the words opposite direction. So understood when they just opposite, that means you need to minus. Okay, normally we take the bigger one minus the smallest one. Okay, so from here, okay, this one is a citation. 5 go to right, 2 go to left. So what is your resultant force? So you just show me what's your answer. Okay. Okay, you just type in the chat room. Okay, type in the chat room, then we know the what you write there. Okay, let's see anybody can answer this question. 5 and 3. Sorry, 5 and 2. Okay, Nixon answer me already. There's a 3 Newton go to right. Okay, some more. Beside Nixon, Charan is there or not? Okay, KJ Sin. Uh, okay, go to the right also. Okay, so I pin the answer for Sharon lah. Okay, so the answer here. Okay, 3 Newton to the right. Okay, 3 Newton to the right. Although I know there's a 3 Newton. Okay, but your answer must be full. So Sharon, they show that there's a 3 Newton to the right. So should be correct lah. Must be the full answer. Okay, so we go to the next part. Okay, now we go to citation 3. The force acting in perpendicular. Okay, no more left, no more right. Now it's a citation perpendicular for the two forces. Okay, now you can see up is a 6 Newton, right hand side is a 8 Newton. So from here, they want you to find the resultant force. Okay, for this one citation, you need to do some drawing. Okay, do some drawing and do some calculation. After that, you can get the resultant force. Okay, let's see here. Okay, first step, you need to draw the perpendicular, just like the square box on rectangular box. Okay, or you can say there's a parallelogram box. Okay, so for this one citation, there's a 90 degree. We just make it become one of the rectangular. Okay, after make a rectangular, so this one is your starting point. From the starting point, you draw until another the point that you draw. Okay, so that means the opposite one lah. The starting point to another opposite starting point. So I find it this one line should be the longest in whole triangle box. This one 8 Newton. If I move the 6 Newton, they go another side here. So that means I can create one triangle with perpendicular angle here. So this one should be the longest one, is it? So this one longest we label there as a F. This one F is stand for resultant force. So that means if one of the force is pull 6 Newton up, another force is pull 8 Newton to the right, finally where's the object to go? The object will move to this direction. So this one we call it as a resultant force. For this one citation is more easier because you can calculate resultant force because this one triangle is a perpendicular. That means you can using your max method. There's a theorem by Pythagorean to find what is the F, is it? So I want you to give me the answer for the F only. No need mention direction first. You tell me what's the F. Okay? And you using the method, you go and do your calculation. Okay, just show me the answer. I will pin here. Okay, calculation for the F using the theorem by Pythagorean. Okay, for this one you can memorize because you learn about the max. 3, 4 must be 5, is it? So 8, 6, 6, 8 must be. So the student, you can write here. So I just wait your answer. Okay, Lena. Okay, Lena, they show me already. Lena Pay. They show me the answer is a 10. 10 what? Ling Han is correct. Ling Han give me the answer is a Newton, 10 Newton. So Renard chain become Newton. Add the word for Newton. Okay, so from here, okay, Ling Han give me the answer is 10 Newton. So 10 Newton is the correct. How to do the 10 Newton? So we do the calculation. So from here, the question they ask you how to find the F. Okay, and also data. So data means this one anchor. So just now I told you resultant force, you not just mention the number. You need to mention direction also, is it? So from here, we need to mention direction. Okay, we show the F first. Okay, this one is a calculation for the F. Okay, 8 square plus 6 square, then you square it, we get it 10 Newton. Okay, now the problem is I need to show how to find the data. Okay, after you find the data, that means you can mention the direction for the resultant force. Okay, let's see how to find the data. Okay, before I go to find, I want to ask, okay, student, anybody here can tell me what's the anchor for this one data? Okay, I don't care what method you use it. Important you tell me what's the data. Okay, we check. Got any student can give me the answer for data or not? Okay, just start here. Okay, I also don't know because I'm not yet sure what's the answer for data. Okay, we got Jessica. Jessica, give me the answer. There's a 36.9. Okay, we see got others or not? Other student. Okay, just Jessica only. So I just pin the answer first. We're going to check is this that Jessica the answer is correct or not. Okay, so we're just using tangent. Okay, I using tangent. There's a 6 and also 8. Okay, 6 over 8. Okay, if you want to using 10 Newton, is okay. Okay, but problem is if the F you find there's a correct, okay lah. If the F you find there's a wrong, example, this one you find 20 Newton, then you want to using cos or sine, that means you get the wrong answer for anchor. Okay, so from here I get the answer. Okay, student here, Alicia Teo also give me the answer 36.87. Okay, Yiru Show also same. Okay, we're going to check. Okay, tangent data 6 over 8, 0.75. Now I want the data only, so I need to tangent -1. Okay, so I get it 36.9. You can give two decimal point also can. Okay, so now I get two answer already. We got 10 Newton, we got 36.9. Okay, now I need to answer what is the resultant force. Okay, so the answer here, okay, this one's a drawing. I put in all the things, 10 Newton and 36.9. Okay, now the answer resultant force is 10 Newton. Okay, then you need to say with 36.9 degrees between, you're talking about the direction. Between where? Between the 10 Newton, that means the F, between the 10 Newton and also the 8 Newton forces. Okay, if you do want to mention the 8 Newton forces, you straightforward to mention this one is a horizontal forces. So this sentence you must mention because this one is a direction. If not, I don't know where's the 36.9. You can say up also can. You can say down also can. So now I mentioned there's a between 10 and 8 Newton, then understood. The location must be here. Okay, so this one is a third citation to find the resultant force. Okay, now we go to citation 4. Citation 4 is not perpendicular. If there's a not perpendicular, that means we cannot use in theorem by calculus. So now we're going to see the citation 4. We got two methods how to find it. Okay, these two methods also need to draw. Okay, drawing. So the first one is a parallelogram method. Parallelogram method, that means you need to draw the shape of the parallelogram. Okay, let's see how to draw. First one, they want you to choose the scale, draw the line, represent the magnitude of the forces, 10 Newton, 2 cm. Just like this one. This one is an example. Because sometimes the question give you 500 Newton. Okay, you don't tell me you want to draw the 500 cm. So that means you must using the scale to represent the drawing. So example, I said 10 Newton is a 2 cm. So that means if this one is 10 Newton, 2 cm, so I just draw about, if they say 20 Newton, then you draw 4 cm only. Okay, so the first one, you set the scale. Okay, number 2, using the ruler and a protractor to draw the forces F1 and F2 from a point to form the two adjacent sides of the parallelogram. So that means this one, the question must tell you, this one is how many angle. That means you set the two line, how long already, then you must set using your protractor to find it. This one alpha is how, what is the angle. Okay, then we try to draw. So we draw the first line. Okay, this one, the first line must be parallel with the F1. It must be parallel with the F1. So from here, I draw the another line. Okay, this one new line must be same parallel with the F2. So you can find it, this one same like the parallelogram shape. Okay, so the angle should be here lah. So now I need to find out the resultant force, is it? So resultant force is always is the last, the line must be longest and also away from the original point. Where's the original point? Original point is here. Okay, so we're going to see the following. Okay, with the aid of the pair of the composers, using the compose, then complete the parallelogram, draw the diagonal. Diagonal means this part, draw until another side. Diagonal from the point of the action of the forces. So the diagonal is represent the resultant force. Okay, let's see the diagonal. So this one is a diagonal line. Okay, so this one actually is a resultant force. So we just label there's a F. So what we need to do later, after you find the F, you need to mention the direction, yes or no. So that means you need to create the angle. So this angle later you also need to find. Okay, this one is a drawing. So we don't have any calculation to find the angle and also the line. Okay, what you need to do, you need to measure. Use a ruler to measure. This one diagonal line is how long. Okay, after you measure, you need to multiply with your scale lah. If example, I'm get it as a 5 cm. Okay, 5 you need to convert become Newton, is it? 5 I need to times this one 2, is it? And 2.5. Okay, so if I say this one is a 8 cm, so what you need to do, this one divided by 8, that's a 4 cm, and 4 times 10, that's a 14 Newton. Okay, depend the skill what you use it. Okay, the next one, okay, it's the same thing. I just write here. Measure the length, use your ruler, then calculate the magnitude of the resultant force using the scale you already chosen. Okay, then you measure the angle. Measure angle, sure, using your protractor to measure this angle is how many. Okay, so I show you the example. Okay, this one is an example 1. Okay, you can see the F2, F1. I got question. You see the question, Okay, diagram that show about the boat. They pull by the two forces with the magnitude. F1 is a 500 Newton. F1 500 Newton. Then the F2 is a 400 Newton respectively. So you need to determine the magnitude and direction of the resultant force using the parallelogram method. So that means they want you to draw. So the first step, we need to set the scale, is it? So we set first. Okay, I set 100 Newton is 1 cm. So that means 500 Newton means 5 cm lah. That means you need to draw exactly 5 cm in the paper. Okay, then F2 is a 400 Newton, so you need to draw 4 cm. Then make sure F2 and F1, the center, the angle must be 50 degree. Okay, so this one I already draw it, so I show you. So this one is what I draw it. Okay, this one is exactly 50, yeah. So I draw the parallelogram shape. Okay, this one must be parallel with the F1. This one must be parallel with the F2. So I need to draw the diagonal line. Then from the starting point, draw until another side point. Then this one is the longest line in whole triangle. Okay, so now step 4, I need to measure. Use my ruler, measure from this point until the end point. That's how many cm. Okay, so from here I get it. The cm is 8.2 cm. Okay, this one is a 8.2 cm. Now I need to convert become the Newton. So I times 100. So there's a 820 Newton. So this one is an answer from drawing, not calculation. Okay, after that, I also need to mention the angle is how many is it. So from here, never using tangent, never using sine or cos, because this one is a parallelogram, then you need to measure by using protractor. Okay, let's see the calculation after I measure. Okay, this one they ask you the angle between the resultant force and also F1. This one is a resultant force, this one is a F1, so they ask about the data. So the data I measure, there's a 20 degree. Okay, exactly 20 degree. Then you need to mention where between the resultant force and also the F1. Okay, So this one is the question separate. They separate the resultant force, then they separate the angle. If the question just one question, they ask you what's the resultant force, that means you need to answer full. There's a 820 Newton and with the angle 20 degree between the resultant force and also F1. Okay, you need to join these two questions, become one of the sentence. If the question just asks resultant force. Okay, so understand or not? So anybody can give me some of the response that you understand about this explanation. Okay, nobody feedback me mean you understand, is it? So I continue with the next part. Okay, the next part also the same thing, but this one citation they want using triangle method. Okay, this one is a citation for. Okay, there's also not a perpendicular, but they want to using triangle method. Okay, City understand, Okay, so I continue with the triangle method. Okay, this one is the same F1. Suppose just now the F1 is here, is it? They just make the F1 go to in front. Then this one is a F2. Then this one is just now the angle alpha. Okay, if using the triangle method, okay, the first one still the same. You need to choose the scale. Okay, after choose the scale from here, need to using the ruler and also protractor also. F1 and F2 you follow. Okay, after that to form the two side of the triangle. Okay, you need to draw the F1 to another side, cannot here. If you draw here, cannot draw triangle. So this one you must put at the back. So that means they start F1 then up to F2. Okay, so this one is a diagram. Okay, F1 is here, F2 is here. After that, from the starting point, you draw the line until go to ending point. So you can find it, the triangle, the longest line must be the F. So this one, the F, we call it as a resultant force. Okay, this one is almost same like the triangle perpendicular just now. They pull up and pull left and right. So finally, where the resultant to go. This one is hard a little bit because they're not perpendicular. If perpendicular is more easier because you can using theorem by Pythagorean, but this one no. Okay, the with angle F2 and also not the straight line. They got sang it a little bit. So from here, what we need to do, we need to find this one F. Okay, you find this one F, you must mention the location, is it? So you must mention about the data. Okay, now we're going to see the third one. Third one, you need to measure the length of the diagonal and calculate the magnitude of the resultant force. So after you draw, then you draw the F, you need to measure. Same like the parallelogram. Because this one, two method is a drawing, not calculation. After that, use your protractor to measure the angle. Okay, so we go to the next. Okay, same question. The question exactly same like the just now parallelogram, but I using another method. Okay, the question is the same, 500 and 400. Okay, but the question they change become using triangle method. So I using the triangle method. Okay, scale first, 100 Newton, 1 cm. So triangle method like this. Okay, I pull the F1 go to left hand side, make it longer only. So another one, the anchor 50 Newton, you need to measure exactly 50 Newton. Sorry, 50 Newton is here. Exactly 50 Newton is here. Okay, then you draw about your F2. Okay, F2 is 400 Newton, so means 4 cm lah. This one F1 is 500 Newton means 5 cm. So from here you go to extend here. So this one become 5 cm, then the F2 become 4 cm. Okay, so now you from the starting point, you draw the whole diagonals, you can say diagonal line until to the F2. So this one, the line should be the longest. Compare the green, compare the red line. So this one line, we call it as a resultant force. Okay, now the anchor is a data. So later you need to explain the location of the resultant force by using this one location of the anchor. Okay, let's see the F. This one is the resultant force. Okay, now I using my ruler go to measure what is the F, how long. So I find it 8.2 cm also. Okay, 8.2 cm multiplied 100, that's a 820 Newton. Almost same like the just now. Okay, so that means you need to draw properly. Yeah. If you not draw properly, that means you cannot get the same answer for two method. Okay, now we go to the anchor part. Okay, anchor between the resultant force and also the F1. That means you want to find the data. We also using the protractor, go to measure. Okay, I also get there's a 20 degree. Okay, that's exactly 20 degrees, same like just now. So between the resultant force and also F1. Okay, so from here I can answer. Now the resultant force is 820 Newton with the angle 20 degree between the F and also the F1. So that one is my resultant force by drawing method triangle. Okay, yeah? Both methods should be the same answer. Just drawing part is different. If the question want you to draw, then you must draw. You cannot calculate to come out the answer. Okay. Okay, now we go to this part. Resultant force on the object in the various state of the motion. A free body diagram of an object is a diagram that show all the forces acting on that object only. So you can see the forces. Later, all the forces acting is for who? For the object. The object you want it to move, or you want the object to stay stationary. The forces we just draw on the object only. We never draw the line is out of the object. So example first one, zero resultant force means R equal W. R is a normal reaction. Okay, everybody also got normal reaction. They're always acting to the up. Okay, another one should be your weight lah. Weight must be go to down. Okay, for this one situation, there's a stationary. The book just on the table, they never move. So we can say that there's a zero resultant force. That means up and down the force should be balanced. So from here, R is equal to the W. Okay, if you say W more than the R, then what to do? The book must go in the table already, is it? So that means no. Okay, now the situation is on the table, never move, unless I say let the book to fall down, and W should be higher lah. But now the book is never fall down, they're just on the table. So R equal to the W. Okay, now you can see the free body diagram of a book on a table. You see all the forces where they at. They're acting on the book, on the object. So they said a free body diagram of an object is a diagram that show all the forces acting on the object only. So you can see all the forces when you just draw, not the table. That's for the object, there's a box. Okay. Now the main subject, not the table, there's a book. Okay, we can see another situation also stationary. Okay, this one zero resultant force also. Now we can see the diagram. Okay, this one the luggage you want to fall down. Okay, but they get blocked. Okay, they're blocked by the another inclined plane. So you find it, they never go down already. So we got weight of the bag, they go downwards. We got normal reaction, go to upwards. Okay, we also got normal reaction from the wedge. Okay, from the wedge, they got normal reaction go to the left hand side. So you can see the free body diagram. All the forces, is it acting to the object? Okay, acting to the object only. They never acting to the inclined plane. They're just acting to the luggage. Okay, because now the main object should be the luggage. Okay, so from here we find out the R normal reaction, W equal cos theta. So this one later I will explain more how come they become cos. Okay, where the data come. Okay, another one, the N should be W sine theta. Okay, both from here, R equal to bottom, left equal to the right. So finally we find it, they never fall down. Okay, so R is acting up. So this one line should be acting down, you see, but this one line you need to find out. This one line is a W cos theta. Okay, W and R is a different direction. So from here we cannot say W equal R. No, there's a out because now situation not flat, they got inclined. So R not same direction with the W. The same direction with this one vertical line. This one vertical line, there's a W cos theta. Okay, now N. N is same like the another force go to the right, is it? So that means they become balanced. So this one go to the right, the force we label there as N. Okay, we do know how many. There's a normal reaction, is it? So another one is go to the right, there's a W sine theta. Okay, this one W sine theta or W cos theta. Now you do know is okay because we never go to further. This citation just want to tell you there's a zero resultant force. Okay, and also all the forces that were acting to the free body. Okay, now with the resultant force. Just now is no, now is with. Okay, example now is moving. The trailer now is moving. Okay, can you see the direction of motion? This one arrow is bigger. Okay, arrow bigger means now it's moving already lah, go forward. Okay, we still need to write out the equation. Then you can see all the forces where they act to the object. Important the object is here. Okay, the weight of the trailer, then we got normal reaction. Okay, up down no changes means up down should be balanced. Now it's left and right. Right hand side is bigger arrow, mean this one forces go forward should be the highest. Okay, now we need to write out the equation. Pulling force, okay, more than friction. Agree? So finally the lorry, the tractor can be go forward. Okay, because the pulling force more than friction. Okay, another one is normal reaction. There's a R, and also weight must be the same. Okay, if not, they will leave out already, is it? So up and down should be balanced. Just left and right is a different. So finally, we find out the free body diagram of the moving trailer. Important, all the direction that acting to the trailer and the lorry, finally, they are moving forward. Okay, this one we cannot say zero resultant force because they got finally the forces. Which one bigger? Pulling force is bigger. So they can go in front. Okay, another situation also with the resultant force. Okay, this part, the rocket. Okay, the rocket is moved upwards, is it? So from here we can say the engine thrust is more than weight and also air resistance. So up more than the bottom one. So finally the up one should be because they go up lah. So you can see the direction of the motion. Okay, the arrow is a bigger little bit means they will finally they go upwards. So from here we can say the free body diagram where they act for the rocket. Okay, finally the rocket is moving, is it? So that means all the line, all the forces when you draw, you must draw to the free body. Now the free body is the object finally then stationary or go to move. Okay, so from here, this one we call it there's a with resultant force. That means you need to do the calculation. Finally, the resultant force is how many? Okay, so that means we got two situations only. One is no resultant force, another one is with the resultant force. Okay, now we go to the Newton's second law. Okay, how many here remember Newton law of motion? We got how many? Okay, this one's the second lah. Okay, remember for the Form 4 syllabus, we got how many Newton law of motion? Okay, you can type here. I want to test the students still remember or not. Okay, Newton law of motion. Okay, total law, we got how many law? Okay, just wait your answer. So, how many know? Okay, anybody can respond. Okay, so we get the answer from here. On soon. Okay, they give me there's a three. Okay, they got three law of the Newton motion. Okay, we find out. First law, anybody remember first law is related to what concept? First law is related to what concept? Okay, everybody also correct. Sharon also correct. Lim Zixuan also correct. Three laws. Okay, Mei Ling also correct. So anybody here remember the first law is related to what concept? We learned before chapter 2. The first law of motion. Yeah, Ling Han, that's a correct. Give me the answer for inertia. Yes, the first one is the inertia. Okay, Mama Sharin also correct. Inertia. Okay, this one is the second law lah. F equal ma, is it? So anybody still remember the third law? Third law is related with what concept we learned before? Okay, KJC also correct. Okay, third law. Now we ask about the third law. Anybody remember the concept for third law? Okay, forget it. Okay, third law, they're just talking about the moving object in opposite direction. Action and reaction. Okay, Ling Han. Some more detail a little bit. Action and reaction. Opposite direction one, is it? The magnitude is the same, is it? Remember, the part for momentum. Okay, related to momentum. Frictional force. No, Muhammad Shari, no frictional force. Okay, remember, momentum one. Okay, we learn about elastic, we learn about inelastic, and one more, what is that? Okay, anybody remember? One more for the momentum action. Okay, normally acting for the rocket lah. Action and reaction, is it? So that one we call what name? Okay, we got momentum, elastic, and inelastic. One more, we call it as a? Forget it. Yeah, from here, Ket Yuan rule. The answer is explosion. Okay, that one, the third law, actually, they explain the concept same like the explosion. Okay, action and also reaction, but in opposite direction. Okay, the magnitude is the same, just they move in opposite direction. Okay, so today we need to go just second law. Second law is force equal to the mass multiplied with the acceleration. Okay, so from here, resultant force is a zero. We just got two situations. One is a rest, when the object is no moving. Another one, you can see the keyword uniform velocity. When I just mentioned uniform velocity, mean you are understood the situation is resultant force equals zero. Because uniform velocity acceleration is a zero, is it? So when I put acceleration is a zero, that means here is nothing. So I can say resultant force is a zero also lah. Okay, so we base on this formula for the resultant force. Okay, now we're going to see the first situation. The object is stationary. Okay, now with a car. Now the car is no moving. There's a rest. Okay, we got any force acting to the free body or not? Although there's a stationary, they sure got forces acting to the object. So the first one sure is a normal reaction. Just now I told you they must go to upwards, balance with the weight. Okay, the weight is go to the down. Okay, for this one situation, we need to explain. Okay, velocity equal to zero because you never move. Acceleration sure is a zero. Resultant force also is a zero. So the equation is W equal R. Okay, because two forces. Okay, force go to up, force go to down. Now it's a balance. So that's why W equal R. Okay, then we go to the second situation. There's a moving uniform velocity. Okay, now the object moving uniform velocity. Okay, moving already. Okay, then the R and also W still here lah. You cannot disappear one. Okay, R and W now show is a balance because the car is moving on the road. Okay, then we got the uniform velocity. Sure, the car is moving already, is it? So we in front and behind sure got the force. Okay, now we got frictional force. Okay, frictional force is on the road. Okay, another forces is a thrust. They go in front. Okay, for this one situation, they already mentioned there's a uniform velocity. So uniform velocity, we write the equation. Okay, velocity already is a constant because you say uniform velocity. Acceleration sure becomes zero. So if the acceleration becomes zero, F equal ma, what's the F? The F also must be zero lah, is it? So this one is a uniform velocity. Okay, how to write the equation? Okay, W equal R. Okay, up and down. But now the situation is balance, is it? So FR also equal to the T. So we find it, the car now is a moving uniform velocity. Okay, all also equal. So just now I show stationary, now it's uniform velocity. So these two situation, the resultant force also is a zero. Okay, now we go to another situation is resultant force not zero. Okay, that means finally they got accelerate. Okay, now the object is moving, uniform acceleration. They got pick up. Okay, so from here the car move very fast already. Okay, you can see the car move very fast. Okay, so from here we still label. Okay, we got R and also the W. Okay, now we also got friction. We also got thrust. Now which one bigger? Thrust bigger or frictional force become bigger? Okay, anybody can answer here? Which one become bigger? T or FR? Okay, for uniform acceleration. Okay, anybody? Okay, uniform acceleration. Okay, you just type here, then I can find out the answer. T or FR? Which one biggest for this situation? Okay, the car is moving very fast already. Okay, you can find out which one force should be highest. Okay, T is bigger than the friction. Okay, from the Horn soon. Okay, we pick here. Okay, from here, sure is a T is higher than FR, is it? The keyword from here is acceleration. If the situation is a velocity, that means you just can say T equal to the FR. Okay, so you will also correct. The answer is T is the biggest. Okay, so from here, we're going to show the equation. Okay, velocity now is increasing. Okay, acceleration not equal to the zero because now you are moving fast already. So that means the resultant force also cannot become zero. So we just write that not equal to the zero. Okay, equation W still equal to the R, but now the situation T is more than the FR. Okay, so this one is another situation for resultant force not equal to the zero. Okay, so formative practice. This one is from the textbook. So now I want to give the answer. That means you can mark it. Okay, from the first question, they want to determine the magnitude and direction of the resultant force in the following situation. Okay, the ball, okay, acting to the right hand side 9 Newton, 17 Newton go to the right, 11 Newton go to the left. What is the resultant force? Okay, Chan Jingwen, hi. So anybody can answer this question? Give me the answer for the resultant force. Okay, we wait the student to answer this question. 9 and 17 is the same direction. Then the 11 Newton is go to the left hand side, opposite direction. So normally we take the biggest number, that direction should be the positive lah. That means final answer, I don't want to get negative. So anybody can answer? Okay, we wait the student to answer it. Okay, we get it already. 15 Newton to the right. Very good lah. Everybody now they know need to put the direction already. Okay, so we get the answer here. Okay, this one is a calculation. Okay, resultant force equal to the 9 plus 17 Newton. Then you need to show. If the question is 2 mark, that means you need to show. You cannot just write the answer. Oh, 15 Newton to write. Okay, if 1 mark is okay, but 2 mark, you see, I need to show like this. Okay, 9 Newton plus 17 Newton. Okay, plus also, then the 11 is the opposite direction. So that means I need to show final answer still 15 Newton to right. Okay, City, correct. Your answer is correct. Okay, if 2 mark, you need to do more show about your calculation. Okay, then we go to question 2. Okay, now it's up and down already. Okay, a boxes they pull by 5 Newton and 2 Newton up, then 13 Newton is go down. So what's your answer? Okay, just show me the answer is downwards or upwards, then give me the magnitude also. Okay, remember, must have the direction. Okay, Queen is here, is it? Queen Arika. Okay, so this one answer should be. Okay, we get the answer from the Lim Zixuan. Okay, Lim Zixuan give me the answer is a 6 Newton downwards. Okay, we got Alicia already. Okay, same. Chan Jingwen also give me down 6 Newton. What means of down 6 Newton? You need mention the Newton first, then go where? Down. Normally, the direction is behind. Okay, we're talking about the value first. Okay, so from here, Chan Jingwen, downward 6 Newton. Help me terbalik. Mention the 6 Newton first, baru go to downwards. Okay, so same like the this one. The answer from the Kate. Okay, Kate Yuan Ru, 6 Newton downwards. Okay, so this one is a calculation. I showed it. 13 Newton. Okay, 13 Newton is go down, is it? This one's the biggest one. So I take this one as a positive. Plus, okay, minus 5 because 5 Newton is opposite direction. I also put the plus, then the negative 2 also because they're opposite direction. Finally, I get positive answer. Positive, there's a go downwards. So I put 6 Newton to downwards. Okay, so correct. The answer is correct. Okay, then we go to the next question. Okay, the next question they show about the forces acting to the ball. There's a kick simultaneously by two players. Okay, now you're going to see one of the players they kick up, okay, 180 Newton. Another player they kick 240 Newton. Okay, now you need to sketch, okay, on a sketch a diagram that show about 240 Newton and also 180 Newton, and the last one you need to draw the resultant force. So this one is a perpendicular, is it? More easier. So we go to sketch first lah. So that means you need to represent the scale. Okay, 180 Newton. Okay, represent by the 180 Newton. You want to represent how many cm? Then you write there. Okay, so we sketch. We no need to follow exactly. We just sketch. Okay, so from here, this one's a 180, this one's a 240. Because this one question never call you to draw the parallelogram. Parallelogram, they need to exactly 180 Newton. Okay, this one just sketch only, so we sketch. Okay, after that, you want to find the resultant force. Resultant force, sure, from here. Starting point, you draw until another side, okay, of the rectangular box. So from here, I draw the rectangular first. Then I show about my resultant force. Okay, this one is my resultant force. So from here, I need to find what's the F, is it? Okay, so I want the answer from the student later. Sketch first. We sketch already. Okay, now this one is an anchor. Okay, between the 2 4 Newton and also the resultant force. Okay, some student ask, must this one anchor? Okay, you can go this part also can. Okay, depend for yours. You can say this anchor, you find this anchor, then you say about, oh, now your resultant force is how many? Between 180 Newton and resultant force also can. Okay, I never mentioned the anchor must be here. You can go another side also can. Depend for yours. Okay, so from here, after I sketch, okay, F is a resultant force. Okay, the second question sure is calculation. calculate the magnitude of the resultant force. Okay, so I just left you to do. Okay, just left this one question let you to do. Then you tell me what's the answer for the F. Okay, remember there's a theorem by Hercules. Okay, you press your calculator, is how many? Then you just type here. Then I check is it correct or not. Okay, so we're waiting. Okay, we still got one more question only lah. Now it's 1 o'clock and 55 already. 300 Newton. Okay, from Alicia. Okay, the others, is it the answer is the same? Okay, Ling Han 300. Yiru also 300. Wen Xuan also 300. Okay, Queen also 300. Okay, now we go and check is it the answer correct or not. Okay, this one is a 300 Newton. Okay, not yet direction. This one just magnitude because the question say magnitude only. Magnitude means value only. So from here, I get it. The answer is 300. Danish, yes. What means of same? You need to write the word same who? Same with siapa. So you write 300. You same with the other, is it? 300. So from here, we get it. There's a 300 Newton. Okay, now the next question. They ask you state the direction of the motion of the ball. So if direction, that means you need to find the angle. Then you need to mention where's the direction of your resultant force. Okay, so anybody just give me the answer for angle. Okay, I want the angle that I draw, I show here. I want this angle. So that means you can using the tangent. Tangent 180 over 240. Then you go to reverse one shift tangent. So you can get tangent -1. Okay, give me an answer for the angle. Okay, we check the answer from the student. Anybody give me the answer for angle? Okay. Today got so many student absent, is it? Can remind you again, you need to key in the your Google form, okay, in the Google Classroom. Okay, we get the answer from the student already. Hong Wen Xuan, they give me the answer is 36.87. Okay, so Ru also give me 36.9. Okay, almost the same. So we go to check. Okay, move along the direction of the resultant force. Okay, so this one is the resultant force. Okay, after that we do the calculation. Theta, there's an equal tangent 180 over 240. So from here I get it 36.87. Yeah, correct. Exactly the answer. So from here, how to ask? If I just ask about the resultant force, then you straightforward give me the answer in full sentence. Okay, the resultant force is 300 Newton. Okay, and the angle is 36.87 between resultant force and also the 240 Newton forces. Okay, that one is your perfect answer. What's the resultant force? Okay, so mention the value of the resultant force and also mention the anchor location. Okay, that's the answer. Okay, so my discussion for the 1.1 from your textbook should be finished. Okay, this one is a resultant force exercise. This one is the link. Okay, this one the link I already put inside the description. Okay, the YouTube channel there, they got description. You can see go downwards. You can see my name there. Go down resultant force link. They got one of the link. That one is an exercise link. That means you can click the link. You can download the exercise from there. If you cannot, then you just PM me. I will share you this one link in Telegram. Then you straightforward to click it. Okay, so don't forget to subscribe me. Okay, subscribe me. Then you go to my channel. You can find out more of the video clip can be help you. Okay, maybe related with your topics. Okay, because some of the form 5 they say almost same like the syllabus with yours, just a little bit changes only. So you can refer that. Okay, so that means the next lesson I will discuss about the resultant force exercise. Okay, so got anything to tell you also? Remember to key in the Google form. So my lesson just until this part only. So everybody, hopefully you understand about that. Okay, so just until here lah, 2 o'clock, our class just finished. Okay, everybody, thank you. Okay, thank you. Okay, so from here I also can share a little bit from you lah. Uh, Sorry, I go to show my. Okay, I share here also can. Anybody, I show the comment here. I just copy the link. I share in the comment. Okay, you also can download in the comment. So I put here. Okay, in the chat room. You can see in the chat room. Okay, in the chat room, I already upload the link. So you can refer there. Okay, so everybody just thank you for your enter my class. Okay, thank you. Bye.